here is that kind of distributive property I was talking about with exponents. You are allowed to send the m to both the a and the b because of the parentheses. And here you're allowed to send the m to both the a and the b because of the parentheses. Because remember, when it's outside of the parentheses, this says, hey, I belong to both of these things. So here are the rules. I mean, this is the rule, but it's just written twice. The only extra to this is that you cannot ever divide by 0. Remember, that is written in stone. Okay, cannot divide by 0. Not a thing. Sorry, excuse me, I needed a sip of water. Ooh. So we're going to work on some examples. I want you to pause the video and give it a whirl. Press play when you are ready. So this is -2 to the 4th times a to the 4th. So let's make sure I'm proper on this, aren't I? There we go, much prettier. So how many negatives is this? 4. So it's going to be a positive. So 2 to the 4th is 2, 4, 8, 16. So I've got 16a to the 4th. Here, remember the 3 can go to everything. So this is 3 cubed times x cubed times y cubed. Which then gives us 3 cubed is 27, x cubed, y cubed. If you want to be like soups fancy about it, you can also redo it like that, but we're trying to get rid of the parentheses, so basically that's the answer we're looking for. For 7, I look at this and I see 3 different parts. I see the C, the D, and the negative. Remember, if the negative's in here, you have to attach it with the 5. So when I look at 7, this is what I see. I see -1 to the 5th times c to the 5th over d to the 5th, right? Mentally I see it, but it helps to, write it down when we're learning. So how many negatives is that? 5. So it's an odd amount of negatives, means that we're going to be overall negative in the end. So I've got negative c to the 5th, d to the 5th. And there you go. So with all of these, I want you to put together what we've done so far. I will do 14 because it's probably the one you look at and you're like, no thanks. I'll do 14, but all of the rest, I want you to try them. And if you feel wonky about them, just come talk to me about in office hours. So 14, let me make sure I'm on screen. All right, yep. 14, I've got 3, 3, A, B, B, B. Okay, so I've got 3's and A's and B's everywhere. So I know that there's going to be some reducing happening. What I would like to do first is just kind of clean up all of these extra parentheses or the outermost parentheses. And again, this is just the way my brain is working. Okay, I totally recognize my brain and your brain, 2 different brains. So if you go a different route, that's totally fine. I mean, it has to be a legal route, right? Yeah. But if I work this one way and you work it another way, it could just mean that they're correct and different. Remember, different, well, I shouldn't say remember. I haven't said this to you yet. Different does not mean bad or wrong. Different doesn't mean bad, doesn't mean wrong. It just means different. Different just means different. It doesn't have a good or bad connotation to it. It can be correct and different. It can be wrong and different, but it doesn't have a connotation of goodness or badness to it. It just means different. Okay? So if you do it differently than what I do it on here, totally fine. Don't care. Again, like I said, there's usually more than one way to do something. If you do different from me, I don't care. I just need to know that you understand the concept. So here we go. After my spiel, sorry. Not trying to lecture you, but I want you to get rid of any kind of old habits or old ideas. So I'm going to distribute this 4, this 5, and that 2 respectively. So I've got 3 to the 4th, a to the 4th, and now this is b. 3 raised to the 4, so that's b to the 12. Remember, because we're multiplying there. And then we've got a to the what? 25th, because that's 5 times 5. B to the 5th. All over 3 squared times a to the 6th, b to the 6th. Okay. Now remember, if they're both in the numerator, we add them. If anything's in the denominator, we subtract them. So totally up to you as to whether you want to do addition first, subtraction first, whatever. Because, again, doesn't matter, because in the land of finding my paper, hang on, there we go. In the land of PEMDAS, multiplication, division, and addition, subtraction are on the same playing field, right? They're at the same level. So it can go either way, but we do technically work left to right. So we'll go addition first. So this is a 3. No 3 here. A and an A. 4 plus 25 is a to the 29th. B to the 12th times b to the 5th is really b to the what? 17. And then down here we've got 3 squared, a to the 6th, b to the 6th. So now we're just going to do subtractions, remember? So this is 3 over 3 squared. So that's 1 minus 2. But here, the way I think of it is that the 2 is the larger number. So it's really 2 minus 1, but the 3 stays below because that's where the bigger number came from. So it's going to stay at the bottom. Now, 29 minus 6. 29 minus 6 is what? 23. So that's a to the 23. B to the 17 over b to the 6th is what? 11. B to the 11th. And there you go. Other than the fact that it's bothering me that 3 isn't symmetric right under A and B, like a little pretty triangle. Beautiful. Okay, so again, work these, please. If you have questions, come talk to me. I'd be happy to go over them with you.